So I'm going to help you with this last few pages in the book. Remember this is a dad joke. He says, what is the proper thing to say when you introduce a hamburger? Okay, so we have to graph this inequality. So we look at it and we go, we have three different methods to graph. The y is by itself, so we're going to use the slope-intercept form. The y is by itself. So the 2 is the y-intercept. The number that's in front of the x is the slope. Okay, there's no number in front of the y-intercept, and so let me get my pen. And so there's a 1 there. So my slope is really 1. But if I want to graph slope, I needed a fraction, so I put it over 1. So the top number tells us to go up, the bottom number tells us to go right because they're both positive. So my first step is to graph the y-intercept on the y-axis. So 1, 2. So there's my y-intercept at 1, 2 on the y-axis. Now it says go up 1, right 1. Up 1, right 1, up 1, right 1, up 1, right 1. So there's all my points. Now I have to join them up. Oh, but wait. Do I use dashed or solid? A dashed or solid line? So we use a dash sign when it's less than or greater than, and we use a solid line when it has an equal sign, less than or equal to, greater than or equal to. So this has an equal sign, so we're going to use a solid line. So let's join the points. Make a solid line. Put some arrows on it. Now we have to decide what side to color. So I pick the easiest point possible that's not on the boundary line. I'm going to pick 0, 0. I'm going to substitute this 0, 0 into the inequality. So 0, 0, I'm going to put it into this. And we're going to check to see if it's true or false. So 0, 0. The y is 0, the x is 0. And now I read this. It doesn't matter which way you read it, you just have to read it to see if it's true or false. 2, and because I'm going this way, I'm touching the big side of the equal sign first, so it says 2 is bigger than 0. 2 is bigger than 0. Is 2 bigger than 0? 2 is bigger than or equal to 0. Yeah, it's true. That means this side is true because this point is true. So if I substitute this point into the inequality, it's true. That means everything from this side is true, and everything from this side is false. Okay, so I have to color the true side. I always color the true side. Now we have to go, do I circle A or B? Okay, so because it's a solid line, we look at the bottom. When we have a solid line, the solution set includes the boundary. It means if I take any point from here, it makes the inequality true. If I take a point from the boundary line, it also makes it true, this statement. But when it's dashed, I can take a point from the solution set here, and it will make it true. But if I choose one from the boundary line, it will be false because it does not include, it excludes the boundary line. Okay, so here, the solution set includes the boundary line. Okay, so it includes the boundary line, it includes the boundary line, and it says what quadrants are part of the solution set. And what does it mean by quadrants? So when I cut my graph into 4 pieces with the x and y axis, this is called the first quadrant, second quadrant, third quadrant, fourth quadrant. And usually they write them in Roman numerals. So that's 1, 2, 3, and 4 is IV. Okay? So let's go back here. What quadrants are touching the solution set? Quadrant 1, 2, 3, and 4. All of the quadrants. So all 4 quadrants are part of the solution, and it includes the boundary line. A. So 1 is A. So 1 is A. Alright, let's do the next one. Oh, not the next one. Let's do number 3. Okay, so that's my y-intercept. That's my slope. Okay, I'm going to use the slope-intercept form to solve it because y is by itself. So it's in the form y equals mx plus b. Okay, so I'm going to put a point at -3 on the y-axis. That's where the line, the boundary line, intercepts the y-axis. Now my slope is -2, but I make it a fraction, so I put it over 1. So the top number is always up and down, and the bottom number is always left and right. So this says go down 2, and this is positive, so it's go right 1. So down to right 1. That looks like an L, so I'm just going to do some more. Just going to do some more to help me draw a nice line there. Okay. Oh, wait. Is it supposed to be dashed or solid? Because it has an equal sign, it has to be solid. So the boundary, or the solution set, is going to include, because it's a solid, the solution set will include the boundary line. You can see here it says include in both choices. Include. Now we have to decide what side is true and what side is false, what side to color. So I'm going to choose the easiest point. You could choose any point you want, but I like to choose easy point. I'm going to substitute this into the inequality and see if the statement will be true or false. I'm going to substitute this into here. So it goes 0. So 2 times 0 is 0. I'm just left with -3. So let's read this. 0 is bigger than or equal to -3. Well, let's check. Here's 0. Here's -3. Yeah, 0 is bigger. 0 is bigger than or equal to -3. 0 is bigger than -3. Yeah, 0 is bigger than -3. So that's true. So that means this point, when I substitute it into this inequality, it makes a true statement. So this side is true. That means this side is false. So every point from this solution set, if I put it into here, makes true statements. Every point from this side, any point from this side, I substitute it into here, makes false statements. And because this is a solid line, it means we want the boundary line included in the solution set. So now let's check the answer. So we're supposed to color the true side there. So what quadrants are we talking about? Let me just, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So all 4 quadrants are touching, because see, we have a little bit of quadrant 3. All 4 quadrants, and it includes the boundary line because the boundary line is solid. So the answer is P. So 3 is P. So go over here. 3 is P. Okay.